Hey, so based on our in-class discussion and textbook reading, my hope is that you have a working understanding of the two types of variables that we will be studying in AP statistics. So let's recall those two types of variables. They're categorical and quantitative. My hope is that you should be able to skillfully construct, describe, and compare distributions involving these data. So today's lesson, we're going to focus actually on quantitative data, but before we begin, I want to do a quick review of categorical data. So let's remember, categorical data describes individuals using groups or categories. So let's recall some examples. So this problem should look familiar, hopefully, to you. In this particular problem, we did have some categorical and quantitative, but for our review, let's take a look. Categories can include state, they could be gender, marital status. Another problem we looked at children's preference for their superpower. So superpower, and so here's our superpower, that is categorical data. We also have male versus female, that's categorical data. Other examples might include your favorite color, what's your cell phone preference, the list goes on and on. So let's not forget that sometimes categorical data might look like quantitative, but if it doesn't make sense to take the average of the list of numbers, if you think it's quantitative but it doesn't make sense to take the average, it's probably going to be categorical. And examples include area code and zip code. Some things to remember. We have, let's zoom in on this a little bit. Some good displays for categorical data could be frequency tables, which I just switched the page. Frequency tables, this is a two-way frequency table. Another way to display categorical data might be a pie chart, or in this case, in this particular problem here, I've drawn out a segmented bar graph. You also have regular bar graphs. Remember, when you're just a quick reference, when you're comparing or looking for an association, if two segmented bar graphs look similar, so if they look alike, then we say there's probably not going to be an association between the variables, because knowing one variable doesn't affect the other. If they look different, then there's most likely an association. And we've done this problem already by now. So that was a quick review. Let's do a quick review now with quantitative data, but I'd like to model with greater emphasis because it's so important that you understand how to describe quantitative data and how to compare. So in today's examples, I think I'm going to take a look at two examples involving quantitative data. So I am going to go to, I think, this freezer problem. And so sorry about that. I wanted to move that around so that you could get a better view of our problem. So let's suppose for a minute that your family really needs to buy a new refrigerator, and because you're in AP Stats, you're asked to help compare fridges that have, you have fridges with freezers on the top and freezers on the bottom, and your family can't decide which type to buy. So when comparing distributions in this course, it's essential that we use comparative language. So I don't ever want you to talk about each distribution separately. Rather, I want you to compare the two. I want you to hit all the points of SOX or SOCV, whichever way you prefer to remember it. Compare at the same time and always use context. So let's take a look at the top distribution and the bottom, and it's a little confusing because the bottom freezers are on top and the top freezers are on bottom, but anyways. So When asked to compare, we want to use some comparative language. So we want to look at shape, outliers, center, and variation or spread. So what I've done for you is I'm showing you a pretty great response, and your response doesn't have to look exactly like my response, but it should capture the big ideas. So the first thing I use is context. I'm referencing refrigerators with bottom freezers versus top freezers. I'm going to talk about how in the bottom freezers you have a right skewed distribution, unlike the refrigerators with top freezers. They're going to have more of a symmetrical distribution. Then you want to speak on behalf of the outliers. I see outliers in the bottom freezers, but I don't see outliers in the top freezers. So you want to use that comparison. There are outliers in one but not in the other while using context. You then want to reference the center. You don't have to specifically pinpoint the measurement in the energy cost for the center, but you do want to say that the energy cost is higher for bottom freezers on average, because remember, this is just an average, that's the center, unlike the energy cost for top freezers. And then you want to speak on behalf of the variation. There is greater variability. There's a wider distribution, wider spread for the bottom freezers versus top. So now I want to switch gears and look at a different type of graphical display, and that is a back-to-back stem and leaf plot. So for back-to-back stem and leaf plots, they can be tricky for some to read, including me. So let's suppose we're asked to compare male and female heights of a random sample of 14-year-olds. This problem is in your book for you to reference or in your notes. I want you to think of a stem plot much like you'd think of a dot plot. Remember, dot plots have horizontal axes and the scale is on the bottom, and it's always going to increase from the left to the right. So think dot plots. So what I'd like to do is to take this stem plot and turn it into a dot plot. So by doing that, I worked ahead a little bit. I rotated both sides of my plot ahead of time, and this is something you don't literally have to do, but instead hopefully you can mentally do. And what I did, it looks a little silly, but I split my male and female, I rotated them horizontally, and then I actually flipped the female, because remember, on the bottom, on a dot plot, your horizontal axis has to go from smallest to greatest. Now these numbers are flipped, but I'm just trying to give you a visual here. You might look a little silly and do it with your head and rotate your head so that you can look at it. Let's just talk for a second. Using comparative, we're going to save our comparative language in our context for formal written evaluation in a minute, but let's just talk for a minute. Let's compare these two distributions. One is kind of symmetrical and the other isn't. Be ready to compare and talk about the differences. Do you see any outliers in in either of the distributions? What about the centers? You don't have to specifically pinpoint an actual measurement, but whose center is higher or whose center is lower? You don't have to mention both, just one or the other. And then the last thing you want to talk about is the variability. Which distribution has greater variation? What you're going to do is you want to talk about all 4 points while using context at the same time and comparative language. So at this time, I want you to pause the video, construct your own written response to the who's taller problem, and remember to use comparative language in context. So in your notes, you should have a problem labeled who's taller. After you're done writing your response, push the play button and check your answer against mine. Good luck. So hopefully at this time you have already written your response. I'd like to show you what my response looks like. I wrote that the distribution of male heights is symmetrical while the distribution of female heights is skewed to the left. Make sure you have left there. There doesn't appear to be any outliers in either distribution. The center or average height for males is higher than the center height for females. Remember, comparison. Talk about the average height using context. And then I mentioned that there's greater variation amongst the male heights. Short and sweet and to the point. I really hope this helped. Calculator.